Hey everyone, Brad here. I picked up a turkey shoot earlier in the year and I've been working on restoring it, and I'm down to the gun section. So this has a kind of a gun you point at the screen to shoot at the turkeys and the different targets, and there's a little X that tracks your gun movement on the screen. And how they accomplish that is they have these optical boards here with six infrared photo transistors, and then on the opposite side is six IR emitters, LEDs basically, light emitting diodes, but the wavelength is in the infrared. Um, and then what they did is kind of slick. They use a little printed on some plastic here. It's got a little slit in it to isolate the light across the photo transistors. And then they have a little optical interrupter here that slides back and forth and blocks those six transistors. And they use what's called a gray encoding instead of being BCD or binary coded decimal. This was pretty popular, I think, back in the 80s when this was made. So there's two of these on each game, one for vertical or left X axis and one for Y axis, so up and down and left and right, or horizontal and vertical. So there's two of these exact boards in there. And what happens is these things, as you can see, it's filthy, dirty. They get scratched up from rubbing against each other. And then on here, there's these two little holes. So there's a metal pin that goes through that actually makes this slide. And these get kind of oblonged out or broken. Later versions, they use like a cam follower. They had a rigid plastic that snaps in or rivets in around them. But you can see it's real flexible, pretty thin. And it does kind of block the light here as these things wear out. So I've got a couple of bad ones where this had been duct taped up and cracked. So what I did is I modeled both of these pieces in CAD, and then I had some made out of FR4, like printed circuit board. So here's one here. And again, this is just basically, it's still flexible, but way more rigid. These holes are very reinforced. They're not gonna wear out at all. I don't think there's any need for any cam followers. And then this is the same one with the little 0.4 millimeter slit in it. What I did find, though, I'll show you here. So you basically put this guy on, and again, that little slit isolates the light to each transistor. And then you put on, it's got the little thing here, top left, and you can see on all the components are labeled top left there. So you put this guy on, and then there's some little nylon followers here. They've got a little lip, so there's enough gap for that to slide without being pinched. Put these four on. And I'll show you this why I have it apart. So there's a little resistor network here, this yellow guy. Originally, this is the one I took out. What they use this for is to limit the current flow for the LEDs. The original was 180 ohms on each LED in series. The problem that I ran into is when I made these out of the circuit board, when the light's passing through, there's literally nothing obstructing it. On the original one, it had to go through two layers of this plastic. So they had quite a bit of current flowing through these IR LEDs. And what I found is the smallest set of holes here kind of got washed out. There was just enough light getting through everywhere that kept that transistor turned on. So I ended up replacing that resistor network with the 330 ohms to each. So basically limited the current, which it's almost like dimming the bulb if you think about it that way. So we're getting less light emitting out of these diodes, and that solved the problem pretty quickly. So I'll put this guy over here. We'll put a couple nuts on. The other thing to note too, at one point I was having an issue. I thought that the width of that slit was, I thought maybe I had gotten it wrong. And to try to save costs, I ended up getting some made out of metal. This is aluminum, but you can see it's the same design I had made. The problem is on these boards, actually, you can see up here that the plus and the minus, they actually carry those on the surface, on the circuit board. So if you put metal in here and sandwich it, you create a direct short between plus and minus 5 volt. So that didn't work out too well. Let me just tighten this up real quick. A little nut driver here. So again, basically what happens is this just gets moved back and forth in here, and that tells the game board what the position is. So I'll switch over. I've got already up on the screen here a turkey shoot board set. There's the gun board actually that decodes everything. There's the board set, and then up here is one of the test screens. So we can test all the switch inputs and all this kind of stuff, but also you'll see that there's these two indicators here. They each have 64 positions on them. So one for vertical and one for horizontal. And then again, here is the board with the optical interrupters. And I will plug it in. It should be on the vertical, if I recall, where I've got connected to the gun board. So there we go. I just plugged it in. So if you watch this and then the vertical position, you can see here, I might be losing the focus by keeping it, but I'm basically just moving this in and out. And you can see that far right bit is changing 0, 1. That's the one that we were having issues with. And I can move it each segment independently really well. And this runs super smooth in here. Again, there's 0 resistance to that sliding back and forth. So as you can see, this solved the problem. So basically what I'll plan on doing is if somebody needs a set, I'll provide, the main interrupter, the board with the slit, and one of the little 330 ohm network resistors. Or if they want to send it to me, I have found on a couple of these where either the LED emitters or the photo transistors have failed, and I bought replacements. So theoretically, you could just send this whole assembly, both of them, to me. I could go through, clean them, rebuild them, replace any bad components, and then send it back with these boards already installed is the other option. So it works quite well. And I had, I think, 50 of all the different components made up. So